Okay, guys. Now, what happens when we're doing this is you've got the sheet in front of you and you have this example on the sheet of paper that's in front of you, okay? And we're going to read the problem and we'll go over it together, all right? And I'm going to be doing some work up here, but you're going to want to be making notes on your own paper so you can go back and look over it. And you know what? I want to ask a question quickly. Do you think it would help if there were lines underneath the problem that would help keep your work in order? Or do you like it to just be open space? What do you think? Open. How many would like lines? Raise your hand. Okay, a few like lines, like order. And how many just really need the open space? You don't really care? So it seems like some people might like lines more. Maybe we'll try it on another one. We don't have lines up here right now, but we may try it on another one at some time. All right, this first one says, during the summer feeding season, a blue whale eats about 4 tons of food every day. That's insane. That's 8,000 pounds of food in one day. I guess that's why we need a big ocean, right? To find 8,000 pounds of food every day. I feel like I eat a lot, but I don't eat 8,000 pounds of food every day. All right. Evaluate the expression 4 times D. Guys, that little dot means times, and we're going to get used to not even seeing that dot anymore. When a letter is next to a number, that means multiply. Okay? So 4 times D, whatever D stands for. And it says when D equals 120. All right? So D equals 120. To find out how many tons of food a blue whale eats in a feeding season of 120 days. All right, so we know that it eats 4 tons a day. But how many tons does it eat in 120 days? Well, it's simple enough. This word evaluate, guys, I'm circling it, so should you. When you see it, it means plug in a value for the variable and then simplify it. Okay? So 4, and then I'm putting parentheses here because when a number is right next to parentheses, what does it mean, Armand K? It means times, right? So I'm going to multiply 4 times 120. Guys, I don't need a calculator to do that. You have that. But I can use the distributive property. What's 4 times 100, Tut? 400. And what's 4 times 20, Simon?
80.
So I'm going to add those two things together and get 480, right? Now let me ask you something, Kai. Is this simpler or is that simpler? Which one's simpler? No, I'm not asking the process. I'm asking which form is a simpler expression, the 4 times 120 or the 480? Which one is simpler? The 480, right? Because it's not 2 numbers, it's 1 number. So when you hear the word simplify, that means write it in its simplest form. That means combine things if you can, right? This is not simplify. That is not as simple as we can write it. This is as simple as we can write it. Okay? This is not simplified. It's not. Okay? It's a number, but it's not simplified. Zach, how would we write it if we wanted it to be simplified? 2/3. We want to reduce it, right? Now it's as simple as it gets. Okay? And guys, here's another thing that you're going to notice. We're just kind of getting to know each other, Cole. Right? I mean, we just met. I love your music, but we're just now meeting for the first time. All right? I like fractions, and the reason that I like fractions is because fractions I can write very exact. Decimals, sometimes I can't write them exactly because they repeat. For instance, this one. This is 0.6 repeating, and that's hard to add to 0.15 repeating. Right? It's just not as easy to write those, to work with those things. But if I had written them as fractions, or not that, let's just say, I don't know, how about 0.1 repeating? Adding 0.1 repeating and 0.6 repeating, is it 0.7 repeating? I don't know. Is that? I don't know. But I know that 0.1 repeating is 1/9, and 0.6 repeating is 2/3, right? And if I want to add those, I just get a common denominator and put them together, okay? So then this would be 1/9 plus, oh, I'm about to lose time, guys. I'll see you on the next example.